main objective in this video is for you to learn how to divide radicals. We've already done that in the past with square roots, but now we're going to work with third root, fourth root, whatever the case may be. And the biggest trick for most of the problems is for you to be able to just rationalize the denominator. So we're going to go ahead and get started. In a problem like this, where I have a radical on top and a radical on bottom, I can simplify it if something goes into each of these. And the reason why I can do that is because they are both cube roots. That would not work if I had the cube root of 3 and like the fifth root of 24. They have to both have the same root. So 3 goes into 3 one time. 3 goes into 24 8 times. So already I've simplified it a little bit. I have the cube root of 1 over 3 times the cube root of 8. The cube root of 1 is just 1, and then in the denominator I have 3 times the cube root of 8, which is 2, and 3 times 2 is 6, so my final answer in an example like this would be 1 over 6. So anytime you have the same root on the top and on the bottom of your fraction, then as long as the number goes into both of the radicands evenly, you can go ahead and simplify the problem before you get started. In most problems, it's going to look something like this, where you're not going to be able to do that. I don't have anything that I can simplify. So I have the third root of 2 in the denominator of my fraction. In order for me to get rid of the radical symbol, I have to have something to that same power. So I have to have 3 2's in order for the 2 to make it out of the radical symbol. I currently just have 1. This is 2 to the first. So I'm going to have to multiply something to this. And if I multiply something to the denominator, I have to multiply that same thing to the numerator. You have to multiply to both the top and the bottom. In order for me to multiply radicals, they have to have the same root. So I'm going to multiply the third root. Since I want a total of 3 2's, and I currently just have 1, I need 2 more. So I'm going to multiply it by 2 squared. And I'm again going to do that to the top as well. So on the top, I have a 4, and then I have the third root of 2 squared, which is 4. So I have 4 third root 4. On the bottom, I have the third root. When I multiply these two together, they have the same base, so I can add the exponent. That's 2 to the third. So for every 3 2's that I have on the inside of this radical, I'm going to have 1 2 on the outside. So this would be 4 third root 4 over 2. Now I can simplify the 4 and the 2 because each of those are numbers that are outside the radical symbol. So 2 goes into 2 one time, it goes into 4 2 times. So my final answer for this problem would be 2 cube root 4. So the only real rule here to make sure at the very end of the problem is that we don't have a radical in the denominator. So I was able to get rid of the radical in the denominator because now I really don't have one. This could be considered over 1, but I don't have a radical in the denominator. So this would be an acceptable answer. So here's another example. Now I have a radical on top and bottom. They're both third roots, so I can look and see if I can simplify the numbers ahead of time. Unfortunately, nothing goes into both 3 and 25, so that method's not going to work. So now I'm going to look and see if I can rewrite 25 at all. 25 is 5 squared. So this is the third root of 3 over the third root of 5 squared. All I did was rewrite the 25 as 5 squared. So now I need 3 5's in order to get out of the radical symbol. I currently have 2, so I need to add 1 more to it. So I'm going to do that by multiplying. It has to be the third root. I already have 2 of them. I only need 1 more, so it's 5 to the first over the third root of 5 to the first. Oops. So now, when I multiply, these are both third roots, so I can multiply them together. 3 times 5 is 15. In the denominator, I have the third root of 5 to the third when I multiplied 5 squared times 5. So the numerator is third root of 15. The denominator, since I have 3 5s, I can trade those in for 1 5 on the outside. And then I cannot simplify these any further because this one's inside the radical and this one is not. So this would be my final answer. So hopefully that's enough for you to go ahead and do the homework on the right.